Objective number 3. Classify systems as consistent or inconsistent. Definition of consistent system of equation has at least one solution. The word at least means one or more. It means can be one, can be two, can be three or more solutions. An inconsistent system of equations has no solution. So we have three situations when we have two lines. We may have the system has one solution, exactly one solution, when we have two lines meet each other at one point. So we say the system is consistent and the equations are independent. In the second case, where the two lines parallel, we will have no solution and we will say the system is inconsistent. And the third case, where we have coincident, that means the two lines are identical, then the system is consistent and the equations are dependent. So we're gonna base on this table to solve for example number 7. In example number 7, we do not need to wrap, but we need to determine the number of solution of the system. Okay, so then I first solve the first equation and the second equation for y. So I want to write them in slope-intercept form. I minus 12x first, and then I divide both sides by 4. So I get negative 3x minus 4. For the second equation, I will add 9x first, and then divide both sides by negative 3. So what do we see is that we have the slope, negative 3, the same for both equation, and the intercepts are different. So this is go back like example number 5, where we have the same slope and different y-intercept. So the two lines will be parallel. And if the two lines are parallel, then we have in this case the middle case, right? So if the two lines parallel, then we will have no solution. So in example number 7, they ask us determine the number of solution. We will say no solution. Okay, and then the problem also said that state whether the system consistent or inconsistent. So we go to the parallel case. The system is inconsistent. The system is inconsistent. And if the system consistent, state whether the equations are dependent or independent, but we have the case of inconsistent. If we have the case consistent, we have to stay more dependent or independent. The consistent happen in the case where we have they meet each other. So right here and right here, right? So the first case, the number 1 and number 3. So if we have number 1 and number 3 consistent, then we can tell it is dependent or independent. So recall that if we have the case coincident, that means they have exactly the same y-intercept and the same slope. So both of them the same.